Okay, 15.1 says try these A. It's on page 190, and it says solve each system of equations, show all your steps. Remember to write the solution as an ordered pair. And I'm going to skip A because we did it in class, and for those we didn't do it in class, we actually did it as a bell ringer. So both ways you should have notes about part A. So B says y equals 4x plus 1 and y equals negative x minus 5. Negative 2x minus 5. So solve the system. Now it says solve them algebraically, and here I'm looking that I can set these equal to each other, because if y's are the same number, then the expressions equal the same number. So I'm going to rewrite that as 4x plus 1 equals negative 2x minus 5. So essentially I'm just taking the y's out and putting these two things equal to each other. Now remember, the first step is to get all my variables on the same side. So I'm going to combine all my x's here. So I will have none on this side, which means all I have left is this negative 5. And over here I'm going to have 6x, because 4 plus 2 is 6x, and then this plus 1. Now some of my students are still combining these, the x's and the numbers, the regular constants. You cannot combine those. They are not like terms. Remember, like terms means they're the same variable to the same power or to the same exponent. Excuse me. So now I have all my variables together. I need to get all the constants on the other side. So that means that I have 6x equals negative 6. And I can divide both sides by 6. That will give me x equals negative 1. Okay, but remember, my answer is supposed to be an ordered pair. So all I have is the x value. I have to pick, it doesn't matter which equation, but I have to pick one of them to check. So I'm going to pick the top one, put in negative 1 there. Okay, for x, and that gives me negative 4 plus 1, which equals negative 3. So that means y equals negative 3. Now the only way I can check it is to put both of these numbers in the other one. So that means I'm saying negative 3 equals negative 2 times negative 1 minus 5 for this second equation here. That's what I'm checking. And it's negative 2 and negative 1 is positive 2 minus 5 is negative 3. So it checks. Okay, we did this in class as well, but I know the first one has a fraction and we get a little creeped out by that. So part C says 5x plus 1, y equals 5x plus 1, and y equals negative 4. This one seems quite simple because where there's a y, right, I'm just going to set these two expressions equal to each other. And essentially this is substitution. It's exactly the same as substitution, it's just both equations are solved for y. So here all my variables are already on one side, so I need to get my constants on the same side. That gives me 5x equals negative 5. And then 5 is being multiplied to x, so I divide both sides by 5. That gives me x is negative 1 again. So again, I need to put negative 1 up into my original equation. Negative 1 times 5 is negative 5, plus 1 is negative 4. So my answer is negative, oops, I don't know what I'm writing over here. It's supposed to be an ordered pair. So x is negative 1 and y is negative 4. There is no way to check it in the second equation because y equals negative 4 is just a flat straight line with a 0 slope. So it has every single x value known. So we've solved this as best we can. And that's all for the Try These A on page 190.